Okay, let's continue the discussion of section 1.4. Okay, so yesterday we already discussed the first part. It's about the solution of radical equations. When you have square root, cube root in the equations, how do you solve it? And now let's move to the second part. The second part is solve equations quadratic in form. Okay. Okay, let's see the example. For example, when we have this x to 4 plus x squared minus 12 equal to 0. Clearly, this equation is not a quadratic equation. It has the power x to 4, so it's not quadratic equation. But you see, if we let u be x squared, if u is x squared, then we see that u squared is x to 4. Then the x to 4 becomes u squared, and x squared is u, and minus 12 equal to 0. Then this is a quadratic equation. And we can first solve for u. And after you get the result of u, you let x squared be u, and you solve for x squared. So that's the strategy. And this method usually called the u substitution, because usually we use letter u to do this substitution. But of course, you can use whatever letter you like. But usually we use that. So this kind of original equation, the original means this. Equation is called an equation of the quadratic type. Or an equation quadratic in form. Equation quadratic in form or quadratic type. Okay, so if with certain proper substitution you can simplify the equation into a quadratic equation, then this is a quadratic type. The second part is to discuss this. So let's see the example. For example, we have the equation like this: x plus 2 squared plus 11 times x plus 2 and minus 12 is equal to 0. Okay. Well, you see, it's already in the shape of a quadratic equation. So if you consider this as u, then it's u squared plus 11u minus 12 equal to 0. So normally, it gives us the hint. So let u be x plus 2. If u is x plus 2, the equation becomes u squared plus 11u minus 12 is equal to 0. Right? So it's not that difficult. And then you do that cross factorization. 1, so it's 1 times 1, 12. Remember, you want to find the positive 11. So you got 12 and negative 1. 12 times negative 1 is negative 12. So you see, you do the cross multiplication. This is 12. The product of 1 and the negative 1 is negative 1. The sum is 11. That's good. So you put x here, x here. Oh, sorry, u here. So it's u plus 12, u minus 1. Then from u plus 12 equal to 0, you get u is negative 12. And from u minus 1 equal to 0, this is all condition. U is equal to 1. So there are two solutions for u. Two solutions for u. And once you get two solutions for u, you have to go back to x. So when u is negative 12, negative 12 is equal to x squared, x plus 2. So x is negative 14. When u is equal to 1, 1 is equal to x plus 2. So x is negative 1. Right? So the solution set is negative 14, negative 1. Set. Okay? So you will do the proper u substitution, and this u normally is suggested in the form of the equation. Second example. We have the equation x squared minus 1 quantity square plus x squared minus 1 and minus 12 equal to 0. It's the same thing, or the similar thing. You see here, if you use your finger to cover this x squared minus 1, this is your u squared and u minus 12. Then the equation becomes u squared plus u minus 12 equal to 0. It's the same equation. I'm sorry, it's different. It's different equation. That is has 11. This one has no 11. Okay, now let's factor it. When you have 11, you factor it like 12 times negative 1. When you don't have 11, you're going to factor it like 4 times negative 3. The reason is that you see, if you do the cross multiplication, you will get 4 plus negative 3 equal to 1. 1 is the coefficient of u. So it's u plus 4, u minus 3 equal to 0. So from here, u plus 4 equal to 0, u is negative 4, or from u minus 3 equal to 0, u is equal to 3. If you are familiar with this process, you can skip this line. It's not necessary. I just want to make the whole computation clear, so I write all the lines. Okay, so you have two solutions. U is negative 4, u is equal to 3. And then you solve for x. So when u is negative 4 is x squared minus 1. And move this negative 1 to the left side, you get negative 3 is x squared. So here is the situation. In the regular solution, if we do not mention we're looking for the solution in the complex number system, we always discuss the solution in the real system. In the real system, this one, it has no real solution. This equation has no real solution. But if we say look for the solutions in the complex number system, then it has solution. Okay? When u is equal to 3, okay, 3 is x squared minus 1, then you move 1 to the other side. 4 is x squared, so x is 2 and negative 2. So these two are the solutions. So the 2, negative 2 is the solution set. Is the solution set. Okay? And the other one. We try to solve the equation x plus 2 square root of x minus 3 equal to 0. Well, this one is not as simple as the first two examples, because this one does not have a clear square, and that suggests you what is the form of u. Here you have x and you have square root of x. I remember that we know square root of x squared is equal to x. Square root of x squared is equal to x. So this x, if you write like this by the formula, then you see the suggestion. So you let u be square root of x, then the equation becomes u squared plus 2u minus 3 equal to 0. Right? So this is very important. Square root of x squared is x, so the x is like this, and this is a u. And factorization. From negative 3, I want 2, so it's a 3 and negative 1. This addition. So it's a u here, so it's a u plus 3, u minus 1. You get u is negative 3, u is positive 1. Just let u plus 3 equal to 0, you get a negative 3. U minus 1 equal to 0, u is 1. Okay, then when u is negative 3, so negative 3 is square root of x. Wow. Square root, this is a principal square root. The principal square root can never be negative, so it has no real solution. It has no real solution. Well, u is 1. 1 is square root of x. You square two sides, you get x equal to 1. So 1 is the only solution. 1 is the only solution. Okay? So this is a slightly difficult problem, because you need to observe some transformation so that you can see the suggestion of u. Okay? So this is the equation quadratic in form. The equation quadratic in form. Let me see if we can get another type. Here. Let's see another one. Let's do more examples. For example, if we have equation, you have a 2x 2/3 minus 5 x to 1/3 minus 3 equal to 0. This is the equation quadratic in form. How? Remember, this power function this power function can be written as a 1 and all these are the same. All these formulas are the same. So here, x to 2/3 can be written as x to 1/3 and then square. Then you will let u be x to 1/3. Then this becomes 2u squared minus 5u and minus 3 equal to 0. Then substitution only change whatever in the formula. It does not change the numbers. It does not change the number. Okay, so and from here you can go to complete the proof computation. So I'm not going to finish it. I'm trying to give you more examples and substitution. For example, if we have 3 x to negative 2 minus 7 x to negative 1 and minus 6 equal to 0. In this case, you will also use a similar property. X to negative 2 is x to negative 1 square. So you will let u be x to negative 1. Remember, x to negative 1 is 1 over x. Later, when you do the sum computation, you will use it. And here, x to 1/3 is cube root. Okay? Then this becomes a 3u squared minus 7u minus 6 equal to 0. And this factorization is a 2, 1, negative 3, 1. And this factorization is a 3, 1, negative 3, and 2. So you do the factorization, you can compute it. And another example. Let's see this one. Z to 1/2 minus 4 z to 1/4 and plus 4. For this one, you should realize that z to 1/2 is z to 2 times 1/4. It then becomes z to 1/4 and then squared. And here z to 1/4 is the 4th root of z. So you will let be u be z to 1/4, and this formula becomes u squared minus 4u and plus 4 equal to 0. And this can be factored as u minus 2 squared equal to 0. It has double solution. Okay, so all these are the possible variation of the formula. How do we use the formula, the method we just developed to solve? And you see that you can always transform those equations into the quadratic equation and use a technique of a quadratic equation to solve it. Okay, so this is our second part of section 1.4, the equation quadratic in form. And then there's a third part, solve equations by factoring. Solve the equations by factoring. For example, we have x to 4 equal to 4x squared. For this one, what is the strategy? We're trying to keep one side 0, the other side as a product. So that's what we do. So we move this 4x squared to the left-hand side. 4x squared. And then you see here, this is x to 4. This term has x squared, so we factor out x squared. Remember, a product is equal to 0. That's very important. Don't change it to any other number. If the product is equal to 0, then either x squared equal to 0 or x squared minus 4 is equal to 0. This is the special property of 0. Only 0 has this property. X squared equal to 0, x is 0. There's no second choice. Here, x squared minus 4 equal to 0, then x is 2, negative 2. X is 2 or negative 2. You take square root of 4, you get the principal square root and the negative principal square root. So there are only three solutions. Actually, this one is a double solution. This is a double solution. So we get the solution set. So after you see here, original equation has degree 4. After factorization, each part of it has only degree 2. So factorization will reduce the degree. Lower degree will give us an easier process. If you have a high degree, it will be more difficult. Okay, so let's see the next. So the whole trick is a factorization. How do we factor it? So for example, the other one, we have x cubed minus x squared minus 4x and plus 4 equal to 0. Okay, so already all the terms on the left-hand side, 0 on the right-hand side. So we're going to group them. The first two terms, we group them together. Last two terms, we group them together. So last two terms, we factor out negative 4, so minus x minus 1. We factor out negative 4. And x cubed minus x squared, we factor out x squared. And then you see here, the first term has factor x minus 1. Second term also has a factor x minus 1. You factor out x minus 1. Okay, now you do have a product equal to 0. Very, very important. A product equal to 0. So either x minus 1 is 0 or x squared minus 4 is 0. X minus 1 equal to 0, x is equal to 1. X squared minus 4 equals 0, x is 2, negative 2. So 1, 2, negative 2 are the solutions. This is a solution set. Okay, so factorization. Let's see another example about factorization. So for example, if you have 4 terms, possibly you can think about a factorization. X cubed minus 3x squared minus 4x plus 12 equal to 0. A similar thing. You keep the first two term and the last two term. So first two terms you factor out x squared. Last two terms you factor out negative 4. And then these both product contain the factor x minus 3. Okay, So the first part give you x minus 3 equal to 0 or x squared minus 4 equal to 0. So x is 3 or x is plus minus 2. Okay? Okay, so this is a third example. So by the factorization, there's some exercise also in the recommended part. So you should really do the practice and make sure you understand. Okay. Okay, so this finished the section 1.4. In the 1.4, we studied several types of equations. The radical equations, the equation quadratic in form, and some special equations so that you can factor it. Not all the equations can be factored. Only a special type of equations can be factored, like this stuffs. In the recommended exercise part, you also have similar process. So when you see those special equations, you're supposed to be able to solve it using our recommended techniques. Okay? Okay, so we finished the section 1.4. We will continue the next section in the next video. Okay, we'll stop this video. Thank you.